Ever since the first studies of the Great Pyramid in Egypt have been...
For centuries, the Great Pyramid was called a solved mystery, until the numbers, the stone, and the evidence began telling a very different story. Ever since the first studies of the Great Pyramid in Egypt were made, researchers have been amazed by the mathematical knowledge encoded into the Great Pyramid. The measurements used in it, even the placement of the Great Pyramid, have caused great interest among Egyptologists. For over a century, the Great Pyramid of Giza was seen as a solved puzzle, a huge structure built by ancient humans using simple tools and large-scale labor organization. But when all the archaeological data about Giza was given to an unbiased AI system, the results showed that the numbers no longer matched, and the physical traces no longer matched the tools supposedly used to create them. What Grok AI found not only challenged the mainstream story, it proved that story was not enough. An explanation that no longer works. For nearly 2 centuries, Egyptology has worked within a widely accepted consensus, so deeply rooted that questioning it has often been treated as a risk to academic credibility. The Great Pyramid of Giza, built around 2560 BCE during the reign of Pharaoh Khufu, is said to have been built by tens of thousands of organized workers using copper tools, wooden sledges, and ramp systems. This explanation is not without support. Hieroglyphic records exist. Worker villages have been found near the Giza Plateau. Tool marks are visible on stone surfaces. Papyri document the logistics of transporting building materials. For both the public and the academic world, the case has long been considered closed. Yet, the numbers built into the structure itself have never fully matched that explanation. The base of the pyramid was leveled to within just 2.1 centimeters across a span of 230 m, a precision equal to roughly a 0.009% difference from a perfect plane. Modern construction standards for large structures usually allow differences of up to 0.1%. The pyramid beats that standard by an entire order of magnitude. And this level of accuracy is credited to wooden squares, plumb lines, and water trenches. Its 4 sides are aligned to true north with an error of only 3 arc minutes, a level of precision that today requires advanced surveying instruments, satellite positioning, and careful astronomical observation. Experimental archaeology has repeatedly tried to recreate these tolerances using the proposed ancient methods. In every recorded case, the results fall short by a full order of magnitude, with errors measured in centimeters rather than millimeters. The construction timeline adds another layer of difficulty. The 20-year time frame recorded in ancient sources would require the placing of about 300 multi-ton blocks every single day. That means 1 block every 2 minutes during daylight hours, continuously for 2 decades. This estimate assumes perfect logistics, no accidents, and no learning curve. No other known ancient construction project demands this level of steady precision under such relentless conditions. The conventional explanation offers separate answers for each of these anomalies when looked at one at a time. The leveling precision is credited to lost techniques. The astronomical alignment is explained through basic star observation. The construction speed is credited to large-scale labor organization. Each anomaly is given its own local explanation. Yet these explanations are never required to work together at the same time. What the conventional model has never achieved is one unified explanation that accounts for all of these factors at once within the same structure, carried out by the same workforce. This gap between theory and the physical reality of the monument has remained in the academic record for more than a century without being fully resolved until a system with no professional reason to protect existing theories began analyzing the entire data set at once. When an unbiased system examines the data. In 2024, Elon Musk's Grok AI was given unrestricted access to the complete body of available data on the Giza pyramids. This included archaeological surveys, construction analyses, astronomical alignment records, studies of mathematical relationships, geological assessments, and toolmark databases collected over more than a century of research. The directive was clear. Analyze the data without theoretical commitment, without professional bias, and without any duty to defend existing interpretations. What appeared was not a new reading of a single anomaly. It was a system-wide pattern spreading across multiple separate categories of data, all pointing in the same direction. The first and most statistically important finding involved mathematical relationships encoded within the pyramid's dimensions. The ratio between the base perimeter and the height is close to 2 pi, the basic constant linked with circles, with an accuracy of about 0.05%. Additional ratios connecting height, base, and slope angle match the golden ratio, phi, a constant not formally described until the time of ancient Greek mathematics more than 2,000 years later. Looked at one by one, each relationship might be dismissed as coincidence. However, Grok identified at least 7 separate dimensional relationships within the same structure that all reflect these constants. The probability that all 7 would appear by chance in a structure built through trial and error without advanced mathematical knowledge was calculated to be statistically negligible. The next finding pushed the implications even further. When the pyramid's height is multiplied by 43,200, the result closely matches the Earth's polar radius. When the base perimeter is multiplied by the same number, the result matches the Earth's equatorial circumference. The number 43,200 matches exactly the number of seconds in 12 hours, a basic unit of time, suggesting that this scaling relationship was not accidental but deliberately chosen. Independent surveyors and engineers who reviewed the method confirmed that the chance of this three-dimensional correspondence appearing on its own within a single structure is effectively zero. This leads to one unavoidable implication. The structure appears to have been designed by people who possessed knowledge of the Earth's dimensions. According to all accepted historical records, such knowledge should not have existed at that time. And if it did exist, the question is no longer how the pyramid was built, but who had the knowledge needed to design it. The traces left by tools and stone. Mathematical relationships, with enough theoretical flexibility, can still be dismissed by some as elaborate coincidence. But physical evidence cut directly into stone allows no such flexibility. Grok's analysis cross-referenced toolmark databases with the granite components of the pyramid, especially inside the internal chambers, the sarcophagus in the king's chamber, and the relieving chambers above it. These elements were made from granite transported from Aswan, more than 800 kilometers from Giza. The results isolated a type of tool marks that do not match any known ancient tool signatures in the entire archaeological record. The issue begins with material hardness. Granite contains quartz crystals that rank 7 on the Mohs scale, the standard system for measuring mineral hardness from 1 to 10. Copper, the hardest metal available in Bronze Age Egypt, ranks only between 2.5 and 3. From a physical point of view, a softer material cannot cut through a harder one in a straight and consistent way. What it produces instead are deflected cuts, pulled off course when meeting harder inclusions with changing depth and uneven surfaces. Modern experiments trying to saw granite with copper tools and abrasive sand consistently produce exactly those results. Without exception, the cuts seen in the pyramid's granite do not behave this way. They keep a uniform depth and straight path even as they pass through boundaries between minerals of different hardness within the same block. This is something that copper tools with abrasive sand in theory should not be able to achieve. The most detailed evidence comes from an object known as the Petrie core, a cylindrical granite sample recovered from the site and first studied by British engineer and archaeologist Flinders Petrie in the late 19th century. Along its surface runs a spiral groove, evidence of tubular drilling. Petrie measured the feed rate of the drill, the distance the tool moved into the stone with each full turn. The figure he found suggests pressure and rotational speed far beyond what any known ancient manual drilling method could achieve. More than a century later, mechanical engineer Christopher Dunn re-examined the same object and concluded that the cut characteristics match one of two possibilities: a diamond-tip drill or an ultrasonic vibration mechanism that transfers energy directly into the stone. Neither appears in any known archaeological record of ancient Egypt. Grok compared the full range of granite tool marks from the pyramid against a database of modern cutting methods, including diamond saws, high-speed rotary systems, water jet cutting, and ultrasonic machining. The closest matches did not correspond to ancient techniques. The system does not conclude that modern intervention took place. What it confirms is that specific granite components within the structure were shaped using a method that current science cannot place within the historical context of ancient Egypt. The tools credited to the builders cannot account for what remains in the stone. Something else produced these results, and that something has left no trace anywhere else in the archaeological record of the civilization believed to have built this monument. When anomalies stop being isolated problems. For more than a century, each anomaly described so far has existed in academic literature as a separate issue. Unusual tool marks have been treated as unresolved technical questions, isolated from mathematical considerations. Mathematical encoding has been framed as a debate about measurement systems, separated from geological context within the structure of traditional research. No one has had both the reason and the authority to place all categories of evidence on the same table and require them to be consistent at the same time. That is exactly what Grok has done. And the result is not the sum of individual problems. It is something fundamentally different. For the conventional construction model to hold, all of the following must be true at once. Bronze Age Egyptians must have achieved leveling precision 10 times greater than modern construction standards using wooden tools and soft metals. They must have reached astronomical alignment beyond the capabilities of their measuring instruments. They must have encoded mathematical constants that they had no theoretical framework to describe, not once or twice, but across at least 7 independent relationships. They must have cut granite with copper tools in ways that modern experimental archaeology cannot reproduce. And they must have accomplished all of this within the same project during the same period using the same technological base. Grok evaluates not each condition on its own, but the probability that all of them are true at the same time. The conclusion is direct. The pyramid does not show the characteristics of a structure built at the limits of a civilization's ability. Structures built at the edge of technological capacity always show signs of learning, early failures before improvement, growing precision over time, and inconsistency across construction phases. The Great Pyramid shows none of these patterns. The highest level of precision does not appear at the end of the process after experience has built up. It is present from the very beginning in the foundation itself, in the first stones that were placed. Whatever knowledge produced this structure was not developing during construction. It was already complete before the project began. This is the most important shift in the entire analysis. It is no longer a question of one specific technique or a single measurement. It is the realization that the entire body of evidence, when forced into coherence, points toward one conclusion. The source of knowledge behind this structure lies outside what the conventional explanation can contain. And this raises a question that has long been delayed but can no longer be avoided. Why does the archaeological record show no trace of the path that led to that knowledge? What the record refuses to show. If the pyramid reflects a level of knowledge that was already complete before construction began, then that knowledge must have an origin. The response of the archaeological record to that question is not vague. It is silent. And that silence itself becomes a form of data. Advanced construction in Egyptian history does not follow the pattern of technological development seen in every other area of human history: pottery, metallurgy, agriculture, writing. Each shows a gradual rise in sophistication through clearly visible intermediate stages. Archaeologists can trace each small step across time. The pyramid sequence does not show that pattern. The step pyramid at Saqqara, built under Pharaoh Djoser, represents the earliest known large-scale stone construction in Egypt. Only 3 generations later, the Great Pyramid of Giza appears with its full level of precision and technical refinement already in place. There is no intermediate record of large-scale failed attempts. No archaeological layer of structures approaching Giza-level accuracy before success is reached. Capability appears without an observable developmental precursor. Geological evidence from the Sphinx site makes the problem even stronger. Geologist Robert Schoch of Boston University analyzed the weathering patterns on the body of the Sphinx and the surrounding enclosure walls. Weathering means the gradual erosion of stone through environmental exposure. 2 main types exist: horizontal erosion caused by wind and sand, and vertical erosion caused by rainfall. Each leaves a different signature on stone surfaces. Schoch identified deep vertical erosion channels on the Sphinx and its enclosure, consistent with long exposure to significant rainfall. The last period when North Africa had enough rainfall to produce this type of weathering ended between 7000 and 9000 BCE. This would place the construction of the Sphinx at least within that time frame, long before the rise of dynastic Egypt as a civilization. The mainstream archaeological response credits these patterns to wind and sand erosion. Grok's geological analysis directly tested this claim by comparing the Sphinx weathering patterns with those found on confirmed dynastic structures across the same Giza plateau. The result is clear. Those later structures show horizontal wind-driven erosion. The Sphinx shows vertical water-driven erosion. 2 structures in the same location, exposed to the same environment over thousands of years, yet showing completely different weathering signatures. This difference cannot be explained by present climate conditions. It can only be explained by differences in age. This creates a direct conflict between 2 independently verifiable measurements. The accepted construction date and the weathering signature cannot both be correct. If the construction date is accurate, the erosion pattern should not exist. If the erosion pattern is accurate, the construction date must be wrong. Schoch presented his geological findings formally at the Geological Society of America conference in 1991 before an audience of professional geologists. None rejected his technical analysis. The strongest opposition came not from geologists but from Egyptologists, specialists without expertise in rock weathering, yet with a clear interest in protecting the established timeline. The Petrie core has been part of the record since the 1880s. The geological analysis of the Sphinx was formally presented in 1991. Mathematical encoding within the pyramid has been noted by independent researchers for decades. None of this changed the academic consensus, not because the data was disproved by stronger evidence, but because each piece of data was handled in isolation, placed into separate compartments, never required to align with the others. A system with nothing to lose by examining the whole picture at once revealed what specialized academic structures were never designed to see: what certainty looks like from the outside. Grok does not identify who built the pyramid. That answer does not exist within the data, and the system is careful in recognizing that boundary. What the analysis produces is not a new conclusion but a clearly measured threshold, a dividing line between what the conventional explanation can account for and what it cannot. On one side of that line are the established facts of dynastic Egypt: administrative records, excavated worker settlements, copper tools found within archaeological context, evidence of large organized labor forces working on the Giza plateau. These are real and they remain intact under any analysis. On the other side are equally real observations: leveling precision beyond modern construction standards, astronomical alignment beyond the measurement capabilities credited to the builders, mathematical encoding that appears thousands of years before its formal recognition, granite cutting traces inconsistent with copper tools, the complete absence of developmental precursors in the construction sequence, and the unresolved conflict between the accepted construction date and the weathering signature of the Sphinx. These observations are measurable, and they are not explained by the evidence on the other side. From this boundary, several possibilities appear, none of them comfortable. Dynastic Egyptians may have possessed a far more advanced construction technology than what survives in the archaeological record. Tools or methods reserved for royal projects and never widely spread, disappearing along with the dynasty that used them. Or the pyramids were built by dynastic Egyptians using knowledge inherited from an earlier culture that existed during the humid Sahara period, when North Africa supported larger and possibly more complex populations than recorded history suggests. Or the geological evidence of the Sphinx is correct, and the Giza Plateau was the site of monumental construction long before dynastic Egypt, carried out by a civilization for which no confirmed historical record currently exists. Each of these is a legitimate hypothesis. None is fully ruled out by the physical evidence. None is fully confirmed by it. What Grok establishes is not an answer to who built the pyramid. It establishes that the question remains unanswered and in fact has never truly been answered. The explanation that has dominated for more than a century is not a conclusion fully secured by evidence. It is a framework supported in part by internal consistency within specialized academic fields and in part by the absence of any system with both the resources and the reason to place all categories of evidence together and demand that they align at the same time. An artificial intelligence system has now done exactly that, and the result is not a strange theory. It is a stark confirmation that the existing one is insufficient. The pyramid still stands. The measurements have not changed. The marks within the stone remain. And the question of what produced all of it, a question that has existed within the academic record for more than a century and been repeatedly delayed, can no longer be dismissed as unserious simply because the conventional answer appears simpler, because simplicity is not evidence of truth. And that may be the most unsettling conclusion of all.